हेलो स्टूडेंट्स, आज हम लोग वन डायमेंशनल वेव इक्वेशन को स्टडी करेंगे। स्टडी करने से पहले हम लोग प्रयास करेंगे कि हम एक्चुअल में प्रॉब्लम्स क्या है उसको समझ पाएँ, नेचर क्या है समस्या का उसको हम समझेंगे, फिर हम उसके सलूशन की तरफ बढ़ेंगे। एज वी ऑल आर सीइंग, फर्स्ट डायमेंशन वेव इक्वेशन इज गिवन del 2u upon del t square is equal to c square del tu upon del square, जहाँ पर c स्क्वायर की वैल्यू t by m है, where t is the tension string and m is the mass per unit of the string or wire. The ratio of t by m will be constant always. With this equation there are some boundary conditions, or we can say there are subject to condition. First is boundary condition, which is given u of 0t is equal to u of lt is equal to 0, and second one is initial conditions, which are u of x0 is equal to fx and del u upon del t is equal to 0 at t is equal to 0. Now we have to solve the given equation to find the value of u, which will satisfy these all the four conditions. Now if we see in graphical way, then our problem can be expressed as there is a wire or a string which is from x is equal to 0 to x is equal to L, which is the length of the string or wire, and this is tightly strength from both of the point x is equal to 0 and x is equal to L. If we see the first boundary condition, at x is equal to 0, the value of function is equal to 0. This means from here the value of function will be 0, and similarly when x is equal to L, then u of xt will be 0, because and del u upon del t is equal to 0 at t is equal to 0 means अगर हमने काम शुरू ही नहीं किया है, अगर हमारी पोजीशन रेस्ट पोजीशन में है, देन del u upon del t 0 हो जाएगा, and the last condition is when t is equal to 0, the function will be fx, there will be no change in the function. Now here a question arises, what is fx? Let's see. If we stretch this string upward, इसको अगर हम खींचें और थोड़ा खींच के छोड़ दें, तो इस जो स्ट्रिंग है इसका मूवमेंट इस तरह से ऊपर नीचे होने लगेगा. तो हमको ये पता करना है कि हमारी जो मूवमेंट हो रहा है इक्वेशंस का, उसकी इक्वेशन क्या होगी फॉर द गिवन वैल्यू ऑफ x एंड t. ठीक है, तो now our problem is this: to solve one dimensional wave equation which will satisfy the two boundary condition and two initial condition, and with the help of these two conditions we will find the equation of the wave. Now this equation of the wave can be found many ways, such as Fourier methods, Laplace method and separation of barrier method. अगर आप लोग को याद हो तो इसके पहले हमने सेपरेशन ऑफ वेरियल मेथड्स को स्टडी किया था, और उसी मेथड्स की हेल्प के साथ हम फर्स्ट ऑर्डर वेव इक्वेशन, फर्स्ट डायमेंशन वेव इक्वेशन को सॉल्व करेंगे. लेट्स सी व्हाट वी हैव डन इन द प्रीवियस लेक्चर, और सेपरेशन ऑफ वेरिएबल मेथड को और अच्छी तरह से समझने की कोशिश करते हैं कि क्या है सेपरेशन ऑफ वेरिएबल मेथड. इन द सेपरेशन ऑफ वेरिएबल मेथड वी अज्यूम दैट the solution of the given wave equation will be in the form of x and into t, where capital X is always a function of x and capital T is always a function of t. Now if u of xt will be the solution of the function, then we have to solve the wave equation del 2u upon del t square is equal to c square del 2u upon del x square. We will find the value of both the derivative from the given solution. So from here equation 2, del 2 u upon del x square will be, t will be constant for the differentiation, and del 2x upon del x square, which can be written in the form t x second derivative of x. Similarly, del 2 u upon del t square can be expressed x times del 2 t upon del t square, which will be x t second derivative of t. Now putting these two values in the given equation, we will find x t double dash c square t x. Now by separating the value of t and x, we will obtain second derivative of t upon c square t upon x second derivative of x upon x. If both values are equal, which is possible only when these both all will be equal to a constant. This is the condition for which both these values will be equal. Now if k, now here we will find the solution for the equation 5th by taking t double dash c square t is equal to k, and second solution by taking x double dash upon x is equal to k, like this. If we take t double dash upon c square t is equal to k, then t double dash minus k c square will be 0, and this way k second solution will be x double dash minus kx will be 0, which are the equations which will provide a solution. If we observe these equations 6, t square minus k c square t is equal to 0 and x double dash minus kx is equal to 0, three cases arises from the equation 6. First, what will be the solution if the value of k is equal to 0? Number second, what will be the solution if the value of k is equal to negative? And what will be the solution if the value of k is positive? So from equation 6, we can find three solutions. Now we will discuss all the three solutions in the form of case 1, case 2 and case 3 like as. When k is equal to 0, then from equation 6, t double dash is equal to 0. This means t dash is equal to c1 and t will be c1t plus c2. Similarly, x double dash 0 is equal to x dash is equal to c3 and x is equal to c3x upon 4. So complete solution according to case 1 will be u of xt is equal to, we have written the solution of xt is equal to x into t. So on multiplying both the values obtained from the equation 6, c1t plus c2 into c3x plus c4. So by this way, for the case 1, our solution is u of xt is equal to c1t plus c2 and c3x plus c4. Similarly, when k is positive, that is k is equal to p square. We have written here p square, since if we take any value of p, then p square will be positive. If so, then from equation 6, which is our base equation, t double dash c square t is equal to p square, or t double dash is equal to p square c square t. Now we will obtain the equation t double dash minus p square c square t is equal to 0. Now if we take, here I have taken capital D is equal to d upon dt. So d square minus p square c square t is equal to 0. This will be equation 7. And for the second equation, this will be x double dash upon x is equal to p square. This implies x double dash minus p square x is equal to 0. Now we change in d form, then it will be d dash square minus p square x is equal to 0, which are the homogeneous equation with the constant coefficient, which we have solved in unit 1. The solution of equation 7 and 8 can be of the type CF plus PI, because right hand side of both the equation is 0, so general solution will be obtained by finding its CF value. So firstly we will find the CF value for the equation 7 by putting m square minus p square c square is equal to 0, which is auxiliary equation for the equation 7, which will give us the value of m is equal to plus minus c, and the complementary solution for the equation 7 will be c1 e to power minus pct plus c2 e to power minus pct. We are all are familiar with this type of CF solution. And for the second solution, equation number 8, we will find m square minus p square is equal to 0. The value of m will be plus minus p is equal to c3 e to power px plus c4 e to power minus px. On combining both the values, we will get the general solution or complete solution for the case second, which will be c1 e to power pct plus c2 e to power minus pct into c3 e to power px plus c4 e to power minus px. Similarly, for the third case, if the value of k is equal to negative, that is minus p square, then from the equation 6 again we will find the equation like this: second derivative of t plus p square c square t is equal to 0, which will give the equation in this form, and second equation will be of the form this. This is also a partial differential equation with constant coefficient, so we will find the auxiliary solution or CF value for the same as we have done in the second. For the equation 12, here we will find the value of m is equal to plus minus IPC, which is imaginary. Then complementary function will be of the type c1 cos PCX and plus c2 sin PCT. And for the second equation, d dash square plus p square x, we will find the solution like this: m square plus p square is equal to 0. This implies m is equal to plus minus p, which will the solution c3px plus c4 sin px. On combining both the equation 14 and 15, we will find the solution for the case third is c1 cos pct plus c2 sin pct into c3 cos px plus c4 sin px. In this way, we have examined all the three cases or all the three solutions obtained from the equation 6 for the different values of case. Now we will see out of three solutions which will satisfy our requirement. In first case, we have obtained a algebraic solution. In the second case, we have obtained a exponential solution which can increase or decrease depending upon the value of exponentials and their constant. And in third case, we have obtained the value in the form of sine and cos function. As we know that the solution obtained in equation 16 fulfills our requirement of the wave equation. So the solution 16 for the given equation 1 obtained by taking k is equal to minus phi square is the solution which will satisfy the requirement for the wave equations. So this will be the solution for the given one-dimensional wave equation. Now now we will find the value of constants involved in this solution c1, c2, c3 and c4 with the help of given subject to condition, that are the boundary condition and initial condition, and see what will the real nature of the solution obtained in equation 16. Thank you.